So let's imagine that we can bring the cost of green hydrogen down to the $2 per kilogram or even cheaper because of rapidly advancing technology. What then does it actually make sense to use hydrogen for? We've seen there's in principle an incredibly wide range of things we could use hydrogen for, but the bottom line is some of these things make a lot of sense and some do not. Many people, for example, currently think that hydrogen is a failure because hydrogen-powered cars have been a failure. But as we'll see, there are other places where it could be much more useful. Now, some people have come up with this idea of a hydrogen ladder, where you look at the different possible uses from unavoidable, where green hydrogen absolutely makes sense, to uncompetitive, where it absolutely does not make sense. So let's look at where different things lie on this, or what the possible uses of hydrogen might be. So the best place to use hydrogen, the no-brainer place, is where hydrogen is already being used. A classic example is making fertilizer. Most of the world's crops are grown using fertilizer, which is artificially fixed nitrogen, and that's made by producing hydrogen, currently by the grey hydrogen approach, and using it to make ammonia, which is the basis for most fertilizers. This is the Haber-Bosch process, which is arguably the most important scientific discovery of all time because it's responsible for feeding probably about 90% of the world's population. Without this process, we could probably only feed 1 billion people on Earth, and we currently have 8 billion people. So 7 billion of you, your lives depend on this process. It's currently responsible for about 1% of global carbon dioxide emissions. And so if green hydrogen is cost competitive, this is a complete no-brainer. If we can get it that cheap, then absolutely fertilizers should be made using this process. Which may mean that the world's fertilizer manufacture, which is concentrated in a few countries, might well shift to countries that can produce cheap renewable energy, like Australia. How about steel making? Well, this is responsible for 5 to 10% of the world's CO2 emissions, so it's a major contributor that's getting comparable to many other things like cars. So we definitely have to do something about this if we want to save the world from global warming. Now, at the moment, why is it so bad? It's very energy intensive. Basically, what you have to do is you take the iron ore, which is normally iron oxide, so iron combined with oxygen, and you have to strip away the oxygen and leave the iron, and other impurities as well. It's a lot more complicated than that. So the normal process that's used at the moment is to mix the iron ore with some form of carbon, like smelting coal or something like this, and heat it up enormously to maybe 1,000 degrees. And so first of all, you need all the energy to heat it up that much, and then when it gets that hot, the carbon in, say, your smelting coal or whatever other form it is, will steal the oxygen from the iron. So you start off with iron oxide and carbon, and the oxygen moves over, so you get pure iron and carbon dioxide, which then escapes and pollutes, leaving you with the iron, which you can then use to build skyscrapers, cars, trains, and whatever. But hydrogen can, at least in principle, do both. Instead of having the iron oxide and the carbon, you have iron oxide and hydrogen gas. You might bubble it through, and that will then strip the oxygen away from the iron to produce H2O, water, which is much nicer than carbon dioxide. And in the process liberates huge amounts of heat, which keeps the whole thing at the high temperatures needed for it to work. So it's entirely possible that green hydrogen could be used to replace the world's steelmaking and therefore cut 5 or 10% of the world's CO2 emissions. There are a number of pilot programs, mainly in Europe, going on about doing this, and it's still early stages. It's unclear how cost effective it's going to be, not very at the moment, but if we can really bring the price of green hydrogen down and perfect this process, it might at some point in the future become cost competitive and definitely much better for the environment. So that's looking fairly good. How about the things that don't look so good? Now, some Japanese car makers bet very heavily on hydrogen-powered cars. Now, the benefit of a hydrogen-powered car is its quick refueling and long range. So what you have is a fuel tank, which contains hydrogen. In this case, it might be heavily pressurized. It's very easy to fill up. You just go to a hydrogen station, much like an existing petrol station, and plug in the filter, the fuel filler, and fill up your tanks. Takes a few minutes, much quicker than charging electric vehicles at the moment. The hydrogen is then sent to fuel cells, which convert it into electricity plus heat, and then that drives electric motors. So it sounds great. However, it's probably already lost the war for the future of car transportation. They failed in the market, basically because battery electric vehicles are better. The hydrogen fuel cell vehicles have the quick refueling and the long range, but they're very complex. They need, for example, cooling, because 50% of the energy from the fuel cell comes out as heat, whereas the battery electric vehicles don't need a cooling system. Having to have a fuel tanks, because hydrogen is low density, even when compressed, these fuel tanks are quite large, so you don't get as much boot space as battery electric vehicles. And so there are far more parts. There are 10 times more parts in a hydrogen fuel cell car. That's more things to go wrong and more expensive to build them. Most battery electric vehicles are much more straightforward. And the total efficiency from, say, wind all the way through wind turbine, transmission lines, all the way to powering your car is about twice as good for a battery electric vehicle as a hydrogen fuel cell vehicle, because you lose energy in the fuel cells and you lose energy in the electrolyzers. Still better than internal combustion engine cars, but not great. So it looks like at the moment the hydrogen fuel cell cars are more expensive, less reliable, and they're far worse performance. So this is probably a battle that the battery-powered cars have won. Though some companies are still trying on the hydrogen. Where hydrogen will be more useful in transport is things that are harder to abate, like, for example, aircraft and ships. It probably won't be actually hydrogen itself. It'll be some fuel synthesized from hydrogen, an e-fuel like methane or methanol or ammonia or something like that. But these could be methanol, for example, could be burnt in not very modified jet engines. So you can use a lot of the existing technology. At the moment, the whole process of taking the hydrogen and turning it into these fuels is expensive, but maybe if the price of green hydrogen comes down enough and people work at the chemistry of converting it into fuels, we can bring the price to useful levels. The main competitor is going to be biofuels, so like take your sugarcane and turn that into bioethanol. And then there's long-term storage. Some people call this the killer application. So the idea is that the best way to produce renewable energy normally is to produce too much, to have too many solar cells, so that even on cloudy days you have enough, because solar cells are currently so cheap. So that means a lot of the time you have basically free energy during the sunny days when it's shining, and so use some of this free energy. At the moment, a lot of it might be used for Bitcoin mining or something like this, but you might use a lot of this free energy to produce green hydrogen, which you then store in hydrogen tank farms. And then, on those rare occasions, it might be only once or twice a year, when you get a long period of heavy clouds and no wind, you might then feed that hydrogen back into some sort of turbine or giant fuel cells and produce power to keep the country going. Sounds wonderful. Some people think it might be the way of the future. The drawbacks are that you might be producing hydrogen using electrolyzers which are only used a fraction of the time when there's lots of free energy around. So it might be hard to pay off the cost of them. Likewise, you might need all the turbines to turn this hydrogen back into energy, which again is only used 1 or 2% of the time. So that means you really have to get the cost of the turbines, the cost of the storage, and the cost of electrolyzers down low to make this cost effective with, for example, batteries. But if you want to go from 95% renewable to 100% renewable, this is certainly one way to do it, and it may well be the best way to do it. That last 5% of renewability in the electricity grid is very hard. Right now, I'd be very happy if we even got as high as 90%, which nowhere in the world is close to that. And I'll worry about the last 5% later. But maybe when we get to that last 5% situation 20 or 30 years from now, this could be a cost-effective solution. So, finally, let's talk a little bit about the politics. A hydrogen-based economy looks a lot like a fossil fuel-based economy. You have energy supplied by a few resource-rich countries. In the fossil fuel era, it might be like Saudi Arabia or the Gulf states or Venezuela or Nigeria that produce most of the world's oil. Then it's transported by tankers and pipelines, and then you actually fill up your hydrogen-powered car much like you fill up a petrol-powered car. So it's all very familiar. The geopolitics, this is part of the attraction. Many of the same companies and the same engineers and experts could work on this. But is it then locking us into an expensive and complex system when there are better alternatives? We've already seen that battery electric cars are just better than hydrogen-powered cars and have eaten the market. Could we find ourselves with rapidly falling battery prices and there are just other better ways to do this? So right now the Australian government and companies like Fortescue are betting very heavily on hydrogen, and probably only time will tell if that's actually a sensible bet.